So today you have to complete other things. Step and frequency response of nonlinear model. And you have to find out raise time, peak overshoot, settling time for the step response of nonlinear model. And frequency response, you have to find out minus 3 dB bandwidth and minus 90 degree bandwidth. 100% command amplitude is 30 degree, that corresponding to 9.23 volts. The conversion already told you, that is 32.5 degree corresponding to 10 volt maximum. So 30 degree is 9.23 like. So 100% command amplitude, that is 9.23 volts. And according to that, it will change here and here also. This voltage. So you can, you are enter this parameter file already in your code. So today you have to do the Simulink bar. In the Simulink bar, here it is shown as step input. So if you are changing the step input to the T dash R dash, you will get frequency response. First you have to run deep.m in parameter file, then this model, and last you have to run the dtfa.m to get the sinusoidal response. So step response, you can use this step, and the step voltage is 9.23. For 100% command amplitude, and according to that you have to change the step input and measure the output terminal IO of all element comma 2. So second is the output channel here. So how to convert these things also I explained the last week. So this is a second order filter. So that omega 1 square upon s square plus theta omega s plus omega 1 square. This we are splitting this 1 by s, the omega 1 square is here, then this is coming here, and 2 theta omega 1, and the omega 1 square is coming here, both are negative. So if you are solving this one, you will get this transformation. So just like what you are done in first lab, f is equal to 1 by ml square plus bs plus k, x of s by f of s. So this one how to convert like this, I explained that itself. So like this only it is splitting. This s square term, 2 integrator, you have to split into 2 integrators. That is called state space representation. So state space is doing here, and that 1 by m term is coming here. So everything is done in the first class. The only thing is this one. This compensator block is here, and this overphase flow equation. These two terms are new things for you. And this compensator is this transfer function itself. This transfer function for nonlinear system, you have to use this one. And there you are using a gain block, and the gain is 7.823, and then a transfer function, this one 1 plus 4 by s. So this one you have to just make it like this. transformation model, and then 628 divided by s plus 628, then this transformation. So these 1, 2, 3 transformation is in series, and this is called a compensator. So in Simulink, you can have a option. So if you are having something like this 3 transformation plus this gain, you can just select all the things, and these 3 dots will come. And in the 3 dots, there is one thing called create a subsystem. This one. So you are clicking this one, it will create a subsystem. So it will be like this. So on in, on out will be there, and inside all the blocks will be there. So your some Simulink blocks are more. If your Simulink blocks are more, then in this window, so this window it won't fit. So making that one, you select common things and make a subsystem. So it is actually this compensator transformation, this 3 transformation and this gain. So those things are inside here. So click on this one, you can see that this is a subsystem. So you can do single transformation and cascade it and select all the things. Then here 3 dots will come, and you can make it as a subsystem. So this is easy way to do. That one is the subsystem. This is a compensator. Other things, this one is current limit. So you have to choose plus or minus the saturation block. Saturation blocks in non-linear. And this one also transformation block. This is gain block. This is integrator with limited integrator is there, and this gain, and this one also gain. These are 2 integrators, and these are gain blocks. And this is in this transformation. This also transformation. And this is pure space option. Here you have to choose array format. Here also array format. Here also array format. And this one is max. The only thing is new is here is this orifice flow equation. So the orifice flow equation you can enter in Matlab. So the function you can add in Matlab, that is user defined function. So in the Simulink library browser, there is a user defined function block is there. So you double click on that one, and there is a function called a Matlab function. So this function, the Matlab function, you can drag and drop here. So the Matlab function is, you can create the functions in a Simulink block, that is called embedded Matlab function. So here only one input and output. Here y is and the function of u, and you can write a .m file like this. Here y is equal to u only. So you have to supply here u, and you will get out as y. So this function, you can write whatever the codes you want here. You can change the function name also. You can create input number of inputs also. So in your program, this orifice flow equation, This is a function. This function is function of QE is equal to overface of PL comma Y of I. And this GM is equal to sigma function of I of E. And these things you have to enter in this embedded Matlab function. You double click on this and copy and paste that thing here. So you will get this two and this one. Two inputs it will take and it will give a one output. So like this, you will get two input and one output as this function. PL is taken from here and Y of I, and it will give Q of P as output. So if you are entering this function, function of QE is equal to or this four-phase flow equation, and you have to enter these parameters. These are in that paper itself. So you have to calculate these things for each and every value. So this function will, you are entering this thing and say it will store as a .m file only, that function file only. So you can run here, it will take it from the, that everything will be in same folder. That is only a requirement. Otherwise it will ask the function is missing. So that is the only thing new in this lab, creating a function and creating subsystem. Other things are same as earlier. So you can start doing today. So this max of t is for t dash r dash. If you are giving t dash r dash, and you have to use seep.m and dtfa.m as you are used earlier. And this A parameter, amplitude parameter, you have to make it for the system. Only thing is you have to make a amplitude corresponding to your requirement. And the max of t is the stop time for if you are using these two. And step response you can take some 10 or 20 seconds for those things and measure the rise time, check-in time. These parameters for step command input, rise time, peak overshoot, and settle time. And the sinusoidal response you have to use seep.m and then run the parameter file, then run the Simulink file. Then you have to plot the DTFA. Then you find out minus 3 dB bandwidth and minus 90 bandwidth. So these things you have to do it today. So any doubts is there, you can ask. So if you want any extra class or something, you can just mail us. Sir will take another class if you want. Any doubts or clarification this Friday or next Friday we can arrange. Or in between this lab hours also we can arrange. So you do these things. The disturbance input is 0. This disturbance input is 0 here. You have to take this disturbance as 0. Other things are as earlier. So
So for the integrator, what is the upper and lower limit?
this limit that is there in the paper.
Okay, sir.
You just check it. If you are not getting, I will tell you. So you start doing. So everyone is marked the attendance now.
Sir, when will be the submission for this report? Submission date?
Submission Solution might be, so this, yeah, 28.
Okay.
28 is the last day for submission. After that, 1 week only your class is there now. Your exam is starting on 7th,
18.
18. And then we can, yeah, 28 is fine. So exam will be conducting on this first week or second week. So 28 will be, you can submit it, 28. So any doubt is there, you can 21st or 20 or 23rd we can have a section if you want, 20 or 23. The 28 is Saturday, so you can submit this 28 Saturday. So you start doing. Only thing is these things I think already mailed you, this function. So this is the Matlab function.
Sir, what is WV in the servo valve?
Omega V.
Okay, sir.
This one.